And the quickest way to start to understand why you all are here and what you hope to gain is to understand how many people hadn't heard this term until you saw the title of the talk. Is this a new term for, yep, I'm usually around 50% or more, and this is around a bit 50% or a bit more. So that's about right. How many people here come from more of like an operational background? They've run software in production. They kind of work in sysadmin-y type spaces. Okay, and software development more type spaces. Great. Any testers? That's my title. Yes. All right. And then kind of in project management or other kinds of management, kind of mix. Okay, great. So the entire talk today it should be approachable for everyone, but it's good to know what is in the room so I can maybe target it a little bit. And the reason I think it'll be approachable to everyone is it's about my journey for the last few years of understanding what this term observability means and why it matters to the quality of software that me and my teams produce. And so I started where everybody always starts, with the definition. And I read this. I read that in control theory, observability is a measure of how well internal states of a system can be inferred from knowledge of the external outputs. Which, if it made sense in the way that we all wish it would be a very quick talk. But instead, I sat there and I said, I understand a lot of this, but I'm not sure how to apply this. And so I did what is a super common way of understanding something, is I broke it down into its parts. And the first line here is talking about observability being the measure of something. Being a measure tends to mean that it's a scale and that it can be more or less observable. So I started thinking, okay, so how would I measure observability? Is this something concrete? Can I take out a ruler? How does this work? And when I started thinking about it, I saw this comic, which I had seen a few years previously, and I thought, this might apply. And I thought, the only valid measurement of code quality is WTFs per minute. And when you have a lot of them, you might question your code quality versus when you have fewer. And I thought, this is just as woolly as the term observability. Obviously, you can't take out a ruler for code quality, but there are tools you can use like cyclomatic complexity and test coverage and things to try and get a handle on it, right? But when it comes down to it, it is about how readable and understandable that code is. So I thought, what if I were to translate this a bit, and I were to say, instead of it being a code review, it's a triage room. So now we have an incident, something going wrong with our users. We want to know what's going on. And all of a sudden, now instead of measuring code quality, we're measuring observability. What is your ability to understand new behaviors that are unexpected? How easy is that for you to investigate? That would be better on the scale of observability versus lower. And so I thought, okay, I understand the measurement aspect, maybe a little bit. And I moved on to the second half of this definition. Again, I'm just breaking down these words. It's quite a common way to learn. And I said it's inferring knowledge of its external outputs. So this is about taking the information the service is giving me, application is giving me, and understanding it. And I think, well, we have that. At my company, we use ELK, which is the Kibana and Elasticsearch, but you might use Splunk or something else for logging. We also have ways to track metrics. So we're tracking things like CPU, but we're also tracking things like how many orders people are making. We have tracing so that we can understand when a request comes into our services, how that traverses inside of our architecture, so we can see where things are taking extra time. And we have extra nice graphing tools that help us take those metrics and those logs and put them all together into dashboards. And I think, well, we have all this. We have external outputs that let us understand our systems, right? And we've got an operational engineer, focused person in the room, and you might be thinking to yourself right now, yeah, exactly, monitoring. Why'd you have to come up with a new word for this? And the reason that observability becomes quite interesting is when you start thinking about what monitoring does. Monitoring today is looking at the facts that we already know about the system. We know that CPU, if it gets exhausted, can have impacts on the latency or how fast we can respond to requests. We understand that we have risks about if our database or our file storage starts to fill up, so we track if it gets too full. These are all kind of known knowns that we know we want to track and understand more about. Within our monitoring, we get the ability to ask some new questions, right? We monitor usually lots more things than we know that we need, and we can start to explore what's coming out of there and start adding more understandings. But we also have to make a lot of assumptions because you can't generate information from data you didn't yet put in place. So if you haven't started monitoring something and you want to ask a question of it, that's kind of it. You can't ask that question. And so kind of the pot of gold that observability suggests or sells is that you can actually discover new information, that you can take the data that's coming out of your system and really explore it for unknown unknowns. And in this day and age with distributed systems, the majority of problems that come up are unknown unknowns. We're covering everything else in unit testing and in exploration and in other ways during our life cycle, the delivery life cycle. So we come back to this definition, and I've broken it down. We've talked about lots of the words in it, kind of the sentence and the meaning. So it's clear what observability is, right? Not so much, at least for me. Maybe you all already have, this was enough for you to leave right now and go back and have an impact at your work. But for me, I've been on a much longer journey than just learning what the definition means. And where I started to see that journey come together is when there was a 3-year retrospective put out by Charity Majors, who does a lot of work and has been kind of a spearhead of a lot of this topic in the industry. And in it, she put out what the characteristics of an observable system are. And so all of a sudden, we're adding to that definition that if your system generates raw events without pre-aggregation in a structured format that allows for arbitrarily wide events that don't have a schema, have high cardinality dimensions, and are oriented around the life cycle of a request, that get batched up and allow us to explore rather than dashboard, well, then you're doing observability. And this has helped a lot. I don't mean to make jokes about it, because this is now more concrete. We can start to actually evaluate our systems for these characteristics. But I mean, come on. I just threw so much jargon out at you on that list that, again, your head is swimming and going, no, but just tell me why. Why do I care about this stuff? Why is this helpful to me? How can I apply it? And lucky for you, I'm done with jargon, and I've kind of narrowed in on what I think are 3 kind of key aspects of these characteristics. And I want to tell you stories for each of them about how I thought I was doing them well, and I was very, very wrong. But doing it wrong is what taught me why these characteristics matter. And so I'm hoping that maybe you can learn from my mistakes and understand the reasons behind these as you go back and try and use this. So I'm going to get started with the first one, which is no pre-aggregation. And no pre-aggregation is going to be a story about snowflakes. You'll understand why a bit later on. And it really starts with my introduction to metrics and to monitoring back in 2016, when I attended a conference called Monitorama, which is in the Pacific Northwest in the US. And I'm a software tester, and testing has been dead for years. And I show up to this new conference, new domain I'm really interested in, and I'm told that's dead too. And I'm just like, all right, I know how to pick them. But it's dead, and monitoring is dead, or was being declared as dead as a joke here in this talk, for the same reason testing is often talked about that way, is that we want to get more than just known knowns from these activities. We don't just want to test for things we already know about. We want to understand more about what's going on in the system. Monitoring is just checking for things you already know are a risk. We want to know even more than just those monitoring details. It's actually a great talk. You should check it out. But being at that conference really opened my eyes. I all of a sudden saw the perspective of software delivery from a new angle, from operations where I'd had little to no experience in. And I got to see tools and the data behind the tools, and oh, I wanted my hands on that right away. I thought there was so much opportunity here, and I really want to get involved. And luckily for me, in 2016, it was also the year that the Site Reliability Engineering book came out, which is written by engineers from Google. And I got to learn even more about how this world operates, this hidden world to me. And I learned about the 4 golden signals. And as a software tester, this really sung to me in certain ways, because this is where we start to say we can track quality in production for our end users, for their experiences, for how quickly we respond to their requests, for how many requests we're getting, if we're erroring on them, and all of that. And I thought, this is where I start. It's not enough to track these 4 metrics, but this is where I can start and get a foothold and start to understand this data. And so at the time, I was working with ThoughtWorks, and I said, please put me on a client. I want to monitor live systems. So can you find me a client where this is something that would be beneficial to them as well? And I got an opportunity not long later where I got to join an organization moving to the cloud for the first time. So for them, they were going to take their development platform, so things like their continuous integration server and their source control management system, and put them into AWS for the first time, which meant we had to monitor our new servers in a new way. We had to monitor our services that we were providing developers in a new way. And this was fantastic. And it was everything I'd hoped it would be, right? All of a sudden, the tools, it's all about the tools. It's toys everywhere. I had access now to this ELQ Stack. This is for logging, for Amazon Web Services, AWS. Grafana, where I'm able to graph interesting information and understand its relation to each other. And Prometheus, which is the data behind Grafana. So it's the monitoring and the metrics. And it was this Prometheus that was most exciting to me, because metrics is where you get to track things like latency and errors. They're very cheap to store. They're typically something that you can keep for a very long time, and they're very consistent over time. And so you can watch as your errors change over the days, weeks, months as well, to understand if you can improve there. But I have alluded, I am a test engineer. I'm quite used to things like deprioritization. And similar to testability and testing, operability all of a sudden became hard to prioritize. We had a requirement to move these tools to the cloud. We could do that without adding things like monitoring of those tools, and we could add the monitoring in later. And so I was like, shucks, so close. And we had some monitoring, but it wasn't that exciting push that I was hoping for. Fast forward a couple of years, told you it was a journey. And I joined a company called Moo. And we are a company that sells business cards and other printed goods. So we work with hardware and software. We have our own warehouses. And I have a teammate there, had a teammate, Hobbsy, who had this plan. He was looking at these 4 golden metrics, and he said, I think we can track these consistently across all of our systems, across all of our applications. So we can start to understand where our hotspots are, where we have issues. And he said, if we can track these metrics, let's start with latency. If we can track how quickly we respond to a request for a bunch of time over the last kind of 4 weeks, and we overlay them together as these 4 lines are, we can standard deviation that, and we can say if all of a sudden our response time goes above this standard deviation, call attention to a human, we probably need to do something, right? And then that will trend with us. So if we start to improve our latency, we won't start getting alerts just because, because of that. And so when you see that kind of request go up, we get alerted and it comes back into the normal section and we're in good shape. And so this was exactly what I was hoping to achieve and to be a part of. And so we wanted to do this at Moo. And so at Moo, we are a 15-year-old company with 15-year-old software that's been generated on and off, throughout that time, some newer, some older. Sub any company that's more than a couple years old, and you've got Moo. We have 40 services, which is enough to be troublesome, but not enough to be Amazon scale or anything like that. We have 4 different languages. We have 3 different eras of architectural decisions, 2 different protocols. And it was a lot funnier when it was a December talk, but partridge in a pear tree. But yeah, it felt like, how are we going to make this consistent across all of our endpoints, all of our different services? And this is where Hobbsy did some amazing work. He generated a standardized metric across all of our services via Prometheus, via our metrics, and wrote a recording rule which allowed him to generate this data. And it said that we would get 4 weeks worth of data and track them so that we could look back in time. This was great. Got this merged in. You don't have to worry about the code. It's just fun for later if you want to check it out. But we had some problems with this process. And to understand why we had these problems, now I need to get a little bit detailed about how metrics work and how histograms work. But I promise it's followable, so please stick with me. To talk about how histograms in a time series database work, we have to talk about the fact that each metric, in this case HTTP requests per second, gets broken into buckets. And we get to define the size of those buckets. If you have a very fast endpoint, you might not want to track 5-second long response time. So you get to define this. But that LE is a tag that stands for less than and equal to. So in the case of our website, let's say we had a request to one of our endpoints that took 1/4 of a second. In the case of our histogram, the way that gets tracked is it gets added as a tick mark into each of the buckets where it is true that that number is less than or equal to it. So 1/4 of a second is less than or equal to 1/2 a second, 5 seconds, and infinity, right? So we get a tick in each of those boxes. We keep going. Every request that comes in gets added to the correct buckets. So when we have a very long request, we're uploading images, things like that, it gets added to the buckets it should be in. And so at the end of after Hobbsy committed that code into our repository and we started tracking these metrics, we got left with these buckets full of tick marks, full of counts for 4 different weeks at the different time periods. And this is what your data looks like in Prometheus. And all of a sudden, we got to that 4th week, and we start looking at our dashboards. And oh, it's fun, right? So this is an example dashboard from an internal application called Warhol, where we get to look at things like the slowest endpoints, the highest throughput, the highest error percentage. And now we're giving ownership to the service providers, the software developers, to understand where their hotspots are within their own application. And let alone now across all of Moo, we start to see areas that we can improve across. But I did start this by saying I made a lot of mistakes. And so I think you probably saw mistakes coming from about a mile away. And so I talked about the fact that we get to make assumptions about how we collect this data. And we made some wrong ones, because upfront design, you're bound to learn some stuff. And we learned that having 4 weeks of data is really interesting, but it's also like a lifetime in software delivery, right? Like latency will change much more quickly if you start doing improvements to your software than over 4 weeks. You can do that over hours or days, right? We also learned that the duration of keeping track of the data every 10 minutes was a bit quick, and it meant we had really spiky lines. And actually, we really were looking more for smoothing out of this information. And so we made some changes. We said, we can improve this. We've learned our lessons. We're going to start tracking now this data on a daily basis. We're going to track 7 days worth to create that standard deviation. And we're going to start tracking over an hour instead of over 10 minutes. So we can start to smooth out that number. We understand there's going to be some spikes in there. We still have ways of tracking it. But this is about kind of looking for outliers, and that would help us better. I took all that time to tell you about these buckets that we filled up with all these tick marks that are based on being calculated every 10 seconds, that are based on being calculated over a week instead of over a day. And now all of a sudden, all that data gets thrown away. It was useful. We had some cool dashboards for a bit, but now we have to restart our calculations with these new understandings of how we want to calculate. And so we've done this now. So now we should be all set, right? We should be ready. We've learned our lessons and we're doing things right. But as a tester, I tend to ask questions when I don't understand things. More people should do that. Do that more. And I said, 99th percentile. What's that mean? I got a question. How does that exactly work? Okay, so it's the 99th slowest one, right? But like, tell me more. How does that work? 5 seconds. That's good or bad depending on the endpoint. It's all context. That might be okay. But let's look into what 99th percentile means when it comes to metrics. Well, it's derived. It's magic, right? So in Prometheus, they have these buckets that can tell you if something is the count of things that occurred less than or equal to that duration, that quarter second, half second, etc. But the last bucket is plus infinity. So it's everything. So if you have if you don't have more than 99% of your requests in smaller buckets than infinity, they're kind of guessing at what that 99th percentile is, because all they have is a count going with it. So I said, hang on, what? When this got explained to me, they're like, don't worry, Prometheus handles it. And I was like, oh, yeah, magic. So I was like, okay, well, let me go figure out how accurate this is. Like, we have other data systems that we can look in and understand. And so I took the exact same information. So I took our Warhol application over the last 7 days to this specific endpoint, and I went and I looked at our logs where we track everything. And I said, all right, so we've had over those 7 days 500,000 hits on that. All right, let's go see what's going on here. 5 seconds. What happens if, so to get to 1% of 500,000 requests, that would mean that we'd have 56,000 people request to that endpoint getting 5 seconds or longer on a request. 99th percentile of 5 seconds might not sound so bad, but now you start putting in the context of how many people that impacts, and you start to ask questions of, is 99th percentile enough? Do I need 99.9th, and so on, and deeper? So I say, okay, well, how bad does it get as you keep going? Well, when I started to narrow my search to twice as long as the 99th percentile, so 10 seconds for response time, I'm still getting 309 people having that response time of more than twice as long as the number that we're using to decide where to invest in improving our applications. Maybe that's okay, maybe that's not, that 10-second mark, right? That's for us as a business to decide based on the endpoint and the use cases. But what I want to get across is that we weren't making decisions based on useful information to start with. Now we can. Now we can have a real conversation about what we want to invest in and where and why. But that 99th percentile just hid all of this from us, right? And just to be clear, Prometheus doesn't go above 99th, so I'm not just cutting that short. You cannot get the maximum request time from Prometheus. And so it was amazing to get these consistent metrics, and the trends over time was awesome. But in retrospect, this was about monitoring. It wasn't about mature observability. And so I come back to the point of this story, which is pre-aggregation and staying away from it. And the reason I tell you that this story is all about snowflakes is because imagine a world where you collected snowflakes, where each one is unique, into a bucket. Well, now it becomes snow. And snow can be helpful, but you can never again ask a question about one of those snowflakes, right? So every time that you keep track of metrics with pre-aggregation, where the storage is just a counter instead of the real details, you're losing that ability to ask new questions of your systems. So that's why we stay away from pre-aggregation. So moving on to the next story. The next story is about these arbitrarily wide events. I am going to tell a story this time about going to the grocery store. Again, let's see if you can pick it up now that you know the trend. See if you can pick it up as we go. And this is, I kind of summarized as the fact that data isn't information. Data is helpful, but really what you need to do then is correlate that into information that you can take decisions from. And so go back in time and we talk about logging and the first ever hello world. Anyone in this room that's ever written a line of code or watched anyone else learn how to code has probably written a hello world. And that probably means you've written to the console. You've logged out some information. And it's such a cool experience. The first time you see code that you write print out somewhere, you're like, this is awesome. I want more of this. And so we added more information. As the systems get more complex, as we need more, we start adding information. This is an example for us about our fulfill, so what happens in our warehouses, different methods in which we fulfill the orders, different order numbers, things like that. This has been really helpful to our dev teams. But humans are humans, and when they see value in something, they want more of that something. Chocolate, wine, logs. So now all of a sudden, we've added more details to our logs. And we've got this stream of information that ranges from super high level information to very low level Java descriptions, depending on the log, depending on the statement. So we say, all right, I'd like to be able to search this easier. I think some structure would be nice. So there's a tool that we use that allows us to backfill structure into these pre-existing logs. Again, we're a 15-year-old company. If you've been around a little while, you can't just start with structured logs. So this was our way of starting to allow for kind of a key value pair ability to search things. And this is a real example. We thought that it would be nice to be able to break down the URL because what comes after each of the slashes can give us some information. We have some unique IDs in the URLs, as you might imagine, and therefore you can't see trends over the logs because the unique IDs are troublesome. So we start breaking them down. Humans want more. So we start breaking down the URLs even more than we did originally. And at the time that we did this, we said we would like some more breakdowns of these slashes of the different paths. And how many do we want? I don't know, 3? 3 sounds good. And so we said we have to pick a number because we couldn't do it, ad hoc. And so we picked 3, and now you can see in this table down below what happens when we're wrong, when our assumptions or our guesses are incorrect. Example being on this second line here of where we didn't have 3 parts to our URL. So now we have this ugly kind of URI array 3 bit that gets just auto-filled in. Not the end of the world, because you can kind of treat it like null, because that's what it's saying, but it's not the easiest thing to understand as a new developer either. We also have a situation on this first line where we filled up all 3 slots that we provided, but are there 4? Are there 5? I don't know. We won't ever know unless we go look back in time at the unstructured log at the full length of the URL. So this is where we're at. We're able to add some structure. We're able to search these logs a bit easier now. But to get a little bit further into this arbitrarily wide idea, I want to dig one more depth into how logs work. If you haven't had experience with them, with using them for debugging, you're really lucky. Congratulations. You probably have your sanity still. But you're not supposed to read these. These are not, you can, but you don't need to. But what I hope you can see is the 3 different indicators here. So we've got a solid blue line, we've got a red dotted line, and we've got a green dashed line. And what those are indicating is 3 different servers all sending logs that are all running the same application, all sending logs to the same location. Because they're all the same app, we want to understand how the application as a whole is operating across all the servers. And so they're all in here and they're all intermingled, right? And we have indicators so we can filter and we can search, but when you're first looking through there, it's a lot of information as it streams by. So I'm going to zoom in just a little bit on the blue solid line logs. And I'm going to call out here 3 different log messages. So you can see the bottom one is the first log, so they get added to the top. And so the bottom one says before request. The next one up says that the request was to get available dispatch methods. And the final one is after request. When I first saw this, I did scratch my head a bit. And I went and I talked to the developers. And they had a very good reason for needing this information in the logs. They were doing a short-term project where this was really helpful. But I asked them how helpful it really was, and they were like, well, at first it was really helpful when we were early on in the development, but now it's just too much noise. We don't know what's going on. We don't know how they're all connecting. And you can imagine, right? This is one server that we think those are probably all connected because they're kind of close in time, but there's actually nothing to say that that after request is connected to the one below it. It could be that that's an after request for another one, and how do we know, right? We have to have certain IDs, things that track between them. And so I want to talk about the difference between logs and events. And this has been the most, probably one of the deeper parts of the talk, but also one of the most favorite demos. So hopefully, again, stick with me with the detail. To understand it, you have to understand how logging works. And so again, I'm not going to make any assumptions on what you know, and I'm going to go through from the beginning. So this is a toy app that we've written. I use it for workshops. And what it does, it allows you to upload images, and you can manipulate them. You can flip them and grayscale them and so forth. And in this image, I'm choosing to flip horizontally the image that you can see. So now we're going to pull back the covers and take a look at what it looks like in the code. This is our Java service, Java endpoint. It's flipping an image, and it's asking for the image and whether or not you want to flip it horizontal or vertical. One or both, right? We then do if statements because null checkers, it's Java. And we continue past that, and we hit this log line. And we say, we want to now log out to our system information about this image so that we can debug things. So in this case, we thought that it might be interesting to log out the type of image, because we'd had a bug in like PNGs versus JPEGs. And so we wanted to log out, is this image, what kind, right? That's quite helpful. When we hit this line in code, the way a log works is it just ships it off. This now gets written somewhere, and it gets magically appeared into your log aggregation tool, hopefully. And we continue on our code as we go. And we now actually do the action of flipping. We again make sure null checks. And we again hit another log line because we have more information that would be helpful to us. In this case, now the ID of the image that we've successfully flipped. And I do want to say successfully here. Again, ship our log off. And then we leave that method, and we can see those logs in Kibana or Splunk or whatever tool you might use. And we can see here that we received the PNG image in order to flip it, and we can see that we successfully flipped it, and it has this gibberish of an ID. Now I want to show you that same journey, but doing it with an event rather than with logs. So I've dotted some of the code here to make it a bit simpler, but it's the same method. So we're flipping that image, we're getting the image, and whether or not to go vertical or horizontal. And I decide that content type, what type of image is this? Still important to me. So I want to add that context. But instead of shipping that immediately, I just kind of hold it there. I do the same thing for the fact that this is a flip request, and what the image ID is that's being flipped, and whether it wants to be vertical or horizontally flipped. So I now have all this context about this request in a single kind of held location. I can still choose to ship off logs because logs are still valuable. They give you points in time. They can tell you how things occur in an order, right? So I do that. I also still flip the image, and I can log that I successfully flipped it. Nothing problem there. But now I can add also the field that says I was successful, true, right? And I can return at the end of the method all of that information into a single event. So at the end of this request now, I've got two different types of things in my log aggregation tool. So it's stored in the same tooling, same Kibana. I now have these two log lines, which give me some idea of order of operations that may or may not be helpful now, given that I also have this event which has all the fields with all the different information in it, all combined. So I can ask a question of one single location. So I said, when I say all the information, I've got the fact it's a PNG. I've got all the pieces of this log line, all of these two log lines in a single place, now done in a key value way, which allows me to search easily, filter easily, ask questions easily. I even have more information because instead of me having to go back to my log and figure out how to write successfully flipped image, brackets, horizontal true, vertical false, ID colon. Instead of having to figure out how to add this information into a sentence and just saying, nah, never mind, it's not probably that important, it's so easy for me just to add a new field, put more information in, and see if it's helpful for me in the future. And so what I hope you can see is that the difference between writing out logs versus events is a bit like going to a grocery store. And if you were to go and want to pick up your breakfast food, go into the grocery store, and you were to walk around and you go, oh, great, skim milk, awesome, and just throw it out the grocery store as you're walking around. You go and you pick up your cereal and you just throw the box of cereal out the grocery store, and you pick up your toast and you do or your bread and you do the same thing. Now pay before you leave. So you go up, you pay for all the things you wanted to purchase, but now you have to leave that grocery store and you have to collect your items again, right? That's silly. There's a reason we don't do that. It's even sillier when you think about like a big Sainsbury's and having to try and do that with the hundreds of other people that are throwing their milk and cookies out the door as well. An event is what we all do sensibly when we go to a grocery store. We pick up a basket, and as we walk around, we add the things we want into that basket, and we take it with us. And when we pay up at the register, we get to take that basket out to our cars or in our backpacks and take them home. And why don't we do that with the data in our systems? That allows us to build arbitrarily wide events that have all the context that we could want. So we're on to our third and final story. And this one is quite fun, because dashboards are so fun. I got very excited at all the TVs when I joined Moo, and now I've learned. But why static dashboards might look great, but really are limiting, and exploration is what we're looking for. And that's because, well, debugging systems is hard. And I'm going to get detailed now about issues we've had at Moo, just like every company's ever had. And I think this is where the rubber hits the road with observability, right? Is when an incident is happening, it's impacting your business, it's impacting your customers, and you need to fix it fast, right? So this is a story about pictures and video cameras. So we had an alert come in March that told us that we had some problems with 5xx errors. 500s mean that it's our fault. So this is an error response from the server. 400 tends to mean we can blame the user, rightly or wrongly. 500 though, that's our fault. We should go look into it, all right? And a couple minutes later, yep, definitely an issue. This is our Slack bot that we use in order to raise incidents inside of our company. It's really quite handy. It allows for us to start up an individual Slack channel per incident, which allows us to be able to track all the conversations in one place rather than throughout direct messages and things like you would do in most cases. And so, as I said, a couple minutes later, our customer service team, they go by CS, is fantastic, and they start getting calls and they start seeing the site behaving poorly, and they let us know. So all hands on deck, we jump in the newly created channel, and people start looking at the usual suspects. So we know that we are getting 500s. We know that it's when they're editing one of their packs, when they're editing one of their products. We've got someone who's gone off and looked at those metrics, and that Warhol app that I showed earlier, they're seeing that the 99th percentile is really rising on the request response time. And we now know that the 99th percentile is only a brushstroke, right? Like, it's probably way worse than that for many of our customers. So this could be a problem. We also look in the trace to understand that when you're trying to edit a pack, what are all the services that you are hitting along the way? That'll help us narrow down what could be going wrong in this process and what to not worry about because it's not included in this process. And, you know, there's some errors in the logs. Could that be it? I don't know. If you're not really familiar with what's streaming through those logs on a regular basis, when an incident comes along, every warning and every error log could be the issue. And you don't know, and you have to track that down. So this is a infrastructure developer writing a note about a JavaScript error. He was like, there's errors? Is this important? I don't know. And then the usual culprit, a change. well, there was a change to one of our systems earlier, and maybe that could be it. I don't know. And a couple hours later, we close that incident, and we're still not 100% sure what happened. We know that throughout the entire incident, people were able to order things, so it wasn't 100% downtime, but we also know that there were many customers who were frustrated, and that's not good either. So we don't want that to happen again. We don't know if it will, when it will, why it would. So it's not a comfortable place for us to close this incident, right? So we're not done yet. The worst part about not being done yet is that it did happen again, and again, and again. And we went on for a few months of having these spikes and errors occur throughout, different times. And we were trying to track down what could have caused this and why. And as an on-call engineer, myself and my team, you can imagine it could get quite frustrating to get these alerts. And so here's an example from my team. One of my team members was in a meeting when one of those alerts went off, and he needs to leave the meeting and come check out what's happening. And as his way out the meeting, he asks us to look into it. Another one of my teammates looks into it and notices Warhol again. Same old same. It's that alert that's been going off, facepalm, terrible. But I'm showing you this because it's really easy to be like pointing fingers and saying, oh, like, look at these people. They're letting all these alerts happen for months and months. They can't figure it out. But that's the exact opposite of how our team was operating. They were actually fantastic and doing anything but sitting on their hands. And they had created all sorts of dashboards inside of our logging tool, inside of Kibana, to understand what's going on. And when I started to look into these dashboards, they're actually really cool. So I'm going to show you one of them so you can understand how they use these to uncover the problem over time. So here's the dashboard, and it has a lot of information on it, so I'm going to break it down. Over here on the left, we've got request counts. And over here on the right, we've got response latency, so how long it took to respond to it. The way these are related to each other is that they're related across. So the request counts in the top left is related to the response latency in the top right, and that's referring to enhanced images, which is a type of image inside our system. The next one down is original images, and then enhanced and resized. The reason I have these boxes around them is that the y-axis is set for the two graphs that are grouped together. So the enhanced images and the original images at the top have the same y-axis. So you can start to see that, wow, we don't do very many enhanced images in comparison to original, but they're a bottleneck, right? That is in comparison a problem statement. Similarly, on the bottom, you can see that we don't do much enhanced in comparison to enhanced and resized, but that enhanced and resized makes the big bumps from the top graph look like molehills in comparison, because those two large spikes are really, really harmful. And so we started to realize that the order in which we choose to resize versus enhance is the reason that sometimes this goes wrong, goes sideways. And the dashboard helped tremendously. It helped us identify the incident. It helped us lower the amount of time that the incidents were occurring, even though we were seeing it for months, a few months at a time, until we landed on that last dashboard, which actually solved the problem. The earlier versions of it at least helped us limit it. We saw it coming. We were able to mitigate it faster. So that's great. And eventually, humans created that last dashboard, and now we've had our fix. And we've put in threaded workers. Fantastic. But what do we do with this beautiful dashboard now, right? All the time and energy, it went through maybe 8 iterations to get to the one that found the problem. But now we fixed the problem. That problem won't occur again. So what do we do with it? It enters our graveyard of other dashboards. I had to put on the side here all the ones that we have in our Grafana tool, which is our graphing tool. Again, you don't need to read this to understand that there's a lot of dashboards in there. At the time that I originally, a couple months ago when I put this together, we had 100 dashboards in 16 different folders in Grafana. You try and find one of those. We had 441 visualizations in Kibana that were distributed across 85 more dashboards. Sure, there's a handful of those that are super valuable and that get used all the time, but the vast majority of them have like the word scratch at the end of it, or again, or to, because it's where people are trying to iterate on their ideas and trying to explore the data using the tools that we have. So when I say ditch the dashboards, I don't mean ditch visualizations of your data. I mean ditch the idea that you can create a single pane of glass to understand everything that's happening. Prioritize getting tools which allow for you to do those iterations and do those learnings faster and easier and cheaper, because that's what we're doing in this modern age with distributed systems and microservices and all this kind of stuff, right? And so I love that idea of scar tissue. We talk about it as, business processes being the scar tissue of past incidents. Well, so are dashboards. That's just the technical scar tissue of past incidents. We're no longer going to need these things. Why do we keep them around? So that's my third and final story. And so at this point, I hope you can understand a little bit about my journey to learning about how awesome dashboards are, but also where their limitations are. How amazing logs can be to find information, but how they can be really just, you can end up drowning in the data if you don't organize it correctly. And how collecting metrics gives some information over time, but doesn't give you everything when you don't keep track of the underlying data which generates that smooth line of history. And so the reason I picked those three is that I actually think that they are a good distribution of these topics at whole. When we talk about raw events and no pre-aggregation, we talk about being able to ask new questions by keeping raw data. When we talk about arbitrarily wide events, we also talk about structured data and schemalessness and high cardinality, meaning very detailed data, not very generic data. And this allows us to make it easier to query and more valuable to query the data. Knowing something's true-false versus knowing the details behind it, you can get a lot more. You can always smooth out details to true-false. You can't take true-false and make it detailed, right? And finally, looking at dashboards is similar to looking at the value of an entire life cycle of a request, the entire service, and keeping track of all the context that's useful, because that empowers us to be creative. The humans are involved in technology today, not because we couldn't write code to write code. We already do that. We're there because there are problems that need creative solutions. So let's make sure we empower our people to focus on those solutions rather than on the rote work of the redo. And so I hope that that kind of groupings and those stories will help you understand a little bit about what these characteristics are and allow for you to take them home and start to evaluate if your systems will let you be creative, if your systems will let you ask new questions and feel confident when unknown things are happening. Because that's actually why we use the terminology observability, is to have these conversations. So whatever words you want to use, that's what we care about. And I know many talks start with a description of the speaker, but I actually intentionally left mine to the end here because this entire talk was about me learning, me getting really excited about something and learning that maybe that wasn't the best possible solution for our team and for our organization. And I can promise you I'm still doing things today that I'm going to learn about over the next months and years that I'm going to frown at and say, man, we could have done it better. But that's been my entire career. I started thinking that testing was automation, and then I learned about requirements gathering and questioning things early to get fast feedback. Then I thought that's what testing was, and that's what QA was. And then I learned about what DevOps is and how, regardless of how good the code is in your mind or on your computer, if it doesn't get to production effectively, what good is it? And I started getting really involved in pipelines and those kinds of things. And then I learned about infrastructure and logging and all this observability stuff. But I don't expect this to be the end of my journey. And I think what I really want to get across is if you start digging into this concept, you're going to find people with very strong opinions, with a lot of experience, talking about it, which is a great opportunity to learn from. But it's also 3 years old as a term, right? The skills behind it, yeah, there's lots more history than 3 years. But start where you are and do what you can, and use what you have and do what you can. You don't have to be perfect right at the beginning, because those metrics that we tracked gave us value. Those logs that we have gave us value, and those dashboards gave us value at the time. We just get more value as we've learned how to improve them. Some things that you can maybe try and do to improve your world is to think about asking more interesting questions. Start stepping away from your data and away from your tools before you ask questions of them. Because you're going to be in the context of your tools and of your data when you're asking questions if you're looking at it. But if you step away and you go, in a dream world, I would want to ask this, you can start saying, well, why can't I? It seems reasonable. We know that, technically. We should know that. How can I start to know that by asking our tools about it? And also start building awareness, like that infrastructure dev that very nicely said, do these errors matter in our triage? Like, I don't know. Do they? What if we spent 5 or 10 minutes every day just trolling through the different data that we had to understand what normal looks like, so that when something bad happens, we can know if that's something that's normal or something that's not. Like, build that awareness about your systems. So thank you. I think we have a little bit of time. Yeah, we've got about half an hour, I think, for chat. And I just wanted to call out, I'll be down actually with Seb in London, and there's a discount for joining us at Aginext if you're interested, if anyone wants to take a trip down. So thank you very much. Any questions? What questions? Not any. I know there's got to be one.
You mentioned metrics during the journey, and then it makes me think about obviously requirements, but specifically to what you said, maybe non-functional requirements, response time and all that. What if you don't have that baseline, and then you are told gather the data first, and then we build the baseline. It's basically the opposite of what should happen. Start the baseline, point towards that baseline, then we can have a conversation on how model the baseline over time. But sometimes for NFRs, it's a little bit more complicated. And I wonder if you were in a situation like that, where you were applying non-functional testing in this case without the NFRs.
All the time. So if I were to summarize that, correct me where I go wrong, what happens when you want to improve something, but you actually don't have any data on it yet, and now you have to go through the process from the beginning. You need to collect data to be able to improve it, to see that change in the data. It happens all of the time. There's always something new that you want to explore. I'll give an example actually where a team member at Moo did some really great work. They had decided that the processing time of an image, it's what we do a lot of course, with what our product is, was just too long, and we wanted to improve it for usability. And they said, almost for sure, or they said, enhancing images, we saw that in the graph, that can take a lot of time, we should fix that. And they said, oh, but wait, we should know how long it takes before we fix it so we can show off at the company meeting about how fast we fixed it, right? So they put in the timer into it to get that metric. We didn't have it before. Turns out they were completely wrong. Enhancing wasn't the thing that was the bottleneck. Turns out resizing was. The developer literally said, I think I can resize in Paint by just pulling the corner faster than our services right now, resizing this. But he didn't know that ahead of time. But by thinking in data, by thinking in the fact that it's worth tracking this stuff, he added that in and was able to now track it over time. And I think that's a fantastic way of going about it. It's okay to not have the data. Again, do what you can and add where you can to go. So, yeah.
I'm interested in the choice of tools. So the organization I work for, I work in this area, and we've chosen AppDynamics and Splunk. So
Yep.
It's obviously strong similarities between Splunk and the ELQ Stack. AppDynamics, I think, takes a lot of the work out of what you were doing with Prometheus in terms of trying to identify percentiles and so on. I think there's a great analogy with the snowflakes and the bucket, because that's one of the challenges we have. We're less in control, and we're losing the raw data. But I'm curious as to why perhaps you didn't go for the likes of AppDynamics or Dynatrace or Application Insights or some of these other ones that are kind of trending into the more of the AI ops space, where the tool has the ability to learn what good looks like.
Yep.
Or at least it's sold like that.
for the sake of people on the video, I'm just going to try and summarize that. So basically, the tools that I showed between ELK and Prometheus, so logging and metrics, why not also add in something like an APM, application performance tool like AppDynamics or Dynatrace, I think was mentioned as well, because these tools will allow for learning about what normal looks like, and so they can start to track for you. We have added another tool we use Honeycomb at Moo, which does similar things. I think that, so I don't have experience with AppDynamics, which you mentioned, so I don't want to speak incorrectly on that, but if it doesn't keep raw data, you're losing data, as you said, so I would question that. And the other thing that I've learned through our experience of introducing a new tool at Moo, whatever the tool might be, is the value in the work. So I heard from someone at some point a comparison that some tools try and act like the silver bullet. It's like you go to your doctor and you get told, lose some weight, go to the gym, get healthy. You go home and you grab your tub of ice cream and you sit on the couch and you see a commercial about, a pill that'll make you healthy. And you're like, cool, I like that. Keep spooning that ice cream, right? And maybe it does, right? It probably does help you to a certain extent get healthier, but it will have its limitations because it's not for you. You haven't connected to it the way you would with personal exercise, personal diet, and all that. So I think while it is work, and that means it is less time on feature development or other things to add telemetry to your systems to understand what your events should have in them, what fields matter. To me and to our experiences, that has been the most worthwhile work we've done. We've learned about things like a database call that was in a for loop. So we were hammering our database like 1,000 times for something that needed to be called once. Didn't matter. It added like less than a millisecond of time to our latency. Our database wasn't falling over. There was no known issue there, but it was in a bit of code that no one had really touched. And now all of a sudden they understand that bit of code a bit better. So yeah, so I think it's about investment and about understanding if that's something you want to invest in.
I think Dynamics is also quite expensive too.
Yeah.
You can scale the budget regardless of the context, but it all depends on the value.
Exactly, and it's what value. And so AppDynamics and tools like that can be fantastic in larger organizations that are even more diverse than what I was explaining our tech stack, when you just need to plug something onto a server to get something of value from it, right? Again, use what you need to, right? It's okay to say, yes, I love this, pie in the sky idea of instrumenting all of our code individually and understanding each of it, but we just need to get to the point where we even know what's out there. Use that. Just don't think that you have to use it forever. It could get you to a point where then you can invest in certain other ways of doing this. So, yeah. What other questions? Yeah.
I was kind of wondering if there's so we kind of talked about some tools which are AI trying to do it for you, and some things where it's basically just the UI on top of tracing data.
Mm-hmm.
We have any tools that effectively allow you to train and or call out, either dynamically or in batch, what are the known good and known bad examples?
So are there any tools which will basically do that kind of AI machine learning idea of what's good and bad in your logs or in your metrics?
Well, in particular, the difference we're calling out is where it's guided by a person.
Where it's guided by a person.
Yeah, a person has looked at a thing and said, okay, I think this is a bad trace. Now go find me all other traces that are similar to this.
Yes. I've definitely heard about that. I don't know what tools explicitly do that, but yes, I think that there is tooling out there and is kind of the way of the future. That's that joke about testing is dead and monitoring is dead. There's still an art to identifying what matters to you and your business, and that is a part of it for sure. So yeah.
Data logging. So historically you aggregated logs on a monthly, 6 months, 12 months, and so forth. How long are you keeping data for, and what format are you keeping it in, or are you just dumping data? Are you aggregating it to reduce the space? How do you do that?
Yeah, so the question is, how do you deal with data aggregation with this? How long can you keep data for? How expensive is it? All that. It's a super common question, and I think kind of depends on the organization. So I would suggest not aggregating it. Obviously, that was our story. So, but how do you deal with the cost of that then? And the big thing is actually events can be cheaper than logs in a lot of ways, right? So I showed you an example where we threw off 2 logs for a place where we threw off a single event. Both those logs really aren't helpful anymore. There'll be times when the logs are helpful, but in that case, we could get rid of 2 logs and do 1 event. Now we're not duplicating data. We have a single timestamp field, not 2 of them. We have a single server name field, not 2 of them. We have a single, all these things that were duplicated across our logs is now in one place. So our data is actually smaller and more manageable than it used to be with that. So that's one thing that I think people forget. It also helps with over-the-wire calls, right? So you're only dealing with a event at the end of a request instead of in the middle of your request figuring out what you want to do about should this be synchronous, asynchronous, how are we handling the writes. So there's actually a lot of benefit to doing that. As for how long to keep your data, that is so contextual to your company, right? So with some of the privacy laws, a lot of companies are choosing to dump data after a certain amount of time just for security of peace of mind of not having to worry about it. That might be something you're doing. You might need auditing in order to support, court cases, et cetera, for years. So these are all things that, unfortunately, I can't answer in the scope of observability. It's still the same practices of, do you want the data, how long? But with the added benefit of the data is hopefully more readable and actually smaller if you do the events. So, yeah. What else? Yeah.
Sometimes you'll get a log where things were going along fine, and then the fact that the logging stops tells you something. But if you don't receive the event, you're not going to know where that occurred while it was kind of putting the things in the basket, so to speak.
Yeah.
So it walked out of Sainsbury's without its
No, absolutely. And so there's ways. So the question is with an event, if it gets fired at the end of a method, like what happens to that method errors out if you have an exception and it never finishes. So you can, in most languages, you can use some sort of hooks that basically say like a finally. Like, even if you get an exception, you deal with the fact that you've got this bucket of information that needs to get shipped off. We have been in a place, so we actually just recently had an incident where one of our services, the caching layer ahead of it was having trouble. And so all of a sudden our service just wasn't emitting any logs, but it was emitting metrics. So we could see that CPU was fine, but we weren't getting any information about why this service wasn't responding, and it's because of that. And so you still run into the same problems of if your service doesn't get called, you don't get the logs, but you can put in hooks for your languages that say, ship this off no matter what happens in the service. I've definitely seen that in Java and Python. I would assume that's in every language. So. One more. No? All right. Well, thank you very much. I think we're going to hang out at a pub or whatnot and go out afterwards. So come ask questions in a smaller group if you'd like. Thank you very much.
Thank you very much, Abby.
Thank you very much.
BCS bottle of whiskey.
Very nice.
We're going to go to the pantry where Abby will be answering questions that you were too embarrassed to ask in public. And you're welcome to buy her.
Including about where the heck this accent comes from and anything else.
Exactly. Next month, Gary Fleming will be talking about TDD is my shame. So given that this was quite a technical session, maybe I hope to see a lot of you there as well. And thank you for coming along.
Thank you.
Thank you, Abby.
Yeah.